Hi, I'm Ken Newman, Dr. Ken Newman, and this is a quick presentation on the research that's behind my recent seed grant application on becoming AR ready. So I have said in the abstract that the seed proposal is to establish a basic development pipeline to produce augmented reality simulation and training apps. So it's very much an applied research topic looking at production. Now, Pokemon Go is a form of augmented reality, and it relies on the location services. The Pokemon doesn't know about a person walking in front of it. The Pokemon doesn't throw a shadow. The Pokemon lighting doesn't reflect the real world lighting. But it's not registered to anything in the video. It's just an overlay that sits above the video overlay that the camera sees. Way back in 1997, there's a seminal paper by Azuma, a US naval researcher, who articulates 5 basic problems of augmented reality. So in my research so far, I've been looking at some of the new technologies that are trying to solve some of these problems. And Google Tango is one, which I've already done some work reviewing, and the Microsoft Hololens is kind of the next step. And so it will include the marker behind the table. So this is something very different. This is different to that first photo I showed you where the Pokemon is sitting on a layer above the video. So here we see the monkey occluded by the table. Now, you'll see it's not completely accurate. The mask, the 3D mask has slipped a bit, and there's a little bit of monkey appearing above on top of the table before the occlusion. Tango. By the way, I didn't mention the Google Tango uses an infrared camera, and it projects an infrared beam into the environment and reads back depth sensing, so that it takes that data and builds up a 3D model and feeds that into its area learning capabilities. This is some work that's being done on matching light and shadows. Ball placed into a real-life staircase and is throwing a shadow onto the stairs. For this purpose, I actually developed, I looked in the literature and couldn't find an example of a sort of a shake test, like a standard shake test. So I actually devised one, and I'll use that for comparing, say, the Google Tango tracking with the Microsoft HoloLens tracking. The shake test is simply to move it through a 90-degree shake in 3 rotations 5 times in 1 second, and see what's the maximum of registration error that we get within that test. There are various other field of visual parameters defined by the zoomer, which we can test as well. Field of view, depth of field, orientation, interpupillary distance. So especially when we're looking in stereo, we want to see to what extent the stereoscopic world is replicated with our 3D objects. And of course the big one of occlusion. Here we see an augmented reality game sitting on my desk as I try and do the research. This is a Google Tango application, so it's done a scan of my desk, found an available space, and plonked down this animating 3D city onto my desk, which I can move around in 3D, and it tracks quite nicely. So the goal of this project and this seed research then is to develop some expertise in setting up augmented reality production pipelines. The DIWA is using the Hololens for visualization of power producing operations and facilities. It's also experimenting with remote control and remote access from experts and training. So I think it's the AR simulation and training applications are definitely a space that could be of interest to the HCT. This will be working on things like the realism, the registration, tracking, portability, view parameters, all of the big 5 AR problems. What's the development pipeline? If we wanted to build a training or simulation application using it, where do we start? Presumably we would be building our assets in Maya or in 3D Max or in Cinema 4D. We would be integrating those into a 3D world and using something like the Unity engine, the Unity 3D, to create any behavior or any sort of basic training framework, training intelligence that would need to be there in the app, and then integrating that into the HoloLens, making that that Unity development environment into a HoloLens, executable application. As well as that, there might be a second paper based on the development environments and the development pipeline. From once this is closed off and finished, which I estimate to be about 12 months, then I would think we would be ready to look at an interdisciplinary grant application in the next round. So in October 2018, I would be hoping that we would have a sufficient groundwork to propose a full interdisciplinary grant with a more focus on actually creating usable applications and testing them in a training and simulation environment. HCT, so if you want to make contact with me or you have some questions or feedback on this proposal, then please get in touch with me.